Yeah, okay. Hello and welcome. Thank you for coming the last slot of the last day in the last room of the convention center. We really appreciate your effort. We really are. And this is Mark Galpin, solution architect at JFrog, at Galpin on Twitter.
And this is Baruch Sadogursky. He's our developer advocate, so you probably get to listen to him talk a lot, at JBaruch on Twitter and everywhere else.
Exception. You will hear me talk a lot, because this is what I do. All right, so we're going to talk about how you take your containers to production. Say that's the trust your containers in production, offline and offline, online and offline. And this is what we're going to show you. It will be, most of it will be demo, because that's what you can do in 20 minutes. And we have like 5 slides for you. So this is one of them, and appreciate every one of them because there's not much, right? So, and this is part 1 when everything goes wrong. And that's our normal day at work, of course. And I will start by showing you some terminal here. Isn't it cool? I hope the font is big enough. I'm going to do Docker images on my machine. Everybody use Docker here? No, I'm just kidding. Docker images, and you might have much more images than I do. And I worked really hard to clean it up for the sake of this demo. And let's talk about this one. So this is a nice image. It's called Docker app. Very descriptive, so you have no idea what it is. And it has this marvelous tag of latest. What does it mean, latest? Any ideas? What does latest mean? Guys, we don't have a lot of time. I need answers. What is latest? Nothing. Thank you very much. That's a precise answer. Latest means whatever. It can be a latest image or not. It can refer to a certain image version or not. Basically, it means we have no idea what's going on.
Well, more accurately, it means that latest is something that somebody picked to call latest. The fact that people have expectations around the concept of what latest is a different problem. And it is, to be fair, one, the Docker community as a whole, we're all trying to address. But it's still very common. How many of you have a Docker file that pulls a latest tag?
Don't be shy. It's a horrible thing to do, but we will love you anyhow.
If I don't provide a tag, doesn't it pull the default latest?
Yes, it does.
So in other words, if I have Docker files in Maven, then I'm pulling latest.
And
yes.
You have no idea what you just did.
I have no idea what version.
Yeah, this is how we love it. That's the magic of Docker.
Yes, and by the way, it's not.
I told you I will insult people.
It's not always a bad.
Story, and you expect that is the latest.
Yeah, one of the reasons why Docker tags are so confusing, for people that are used to doing Docker versions, is that Docker actually had somewhat of a really good idea, as much as it sometimes hurts from my perspective of caring about things like, immutable testing and that sort of thing. But the really good idea behind the way the tags work in Docker, sort of by convention, is the idea that whenever I pull an image, it should be one that's patched. Right? So if, even if I don't pull the latest tag, if I pull a specific tag, the idea with Docker is that when I'm pulling a base layer, especially if I'm pulling like an OS image, right? The objective is not to pull the OS image from 2 years ago that has every known day 0 exploit in it.
So, well, as mentioned here, latest actually means latest image you can trust if you download it from a trusted source. This is what it means. For our example, unfortunately that won't work, because imagine that this image was something that was running in your production environment, and now it misbehaves, and actually people ask you to look into it. The problem is that the tag is latest, which means it's a good image. For us it means we really don't know.
Exactly.
Now, there is a solution there. There is something that identifies the image in a very solid and unambiguous way. What it is? ID. Thank you very much. We already been through this part, sorry. And now we already been through that part.
Yes.
I did too much slides, I guess, right? And of course, the ID is what actually helps. And we can get that from the descriptor, from the package descriptor by running docker inspect and getting the ID out of it. And this is what we are going to do. And this is a great, I think that's one of the best signatures I ever saw. The problem is that we still have no idea what it refers to.
It's 6322B.
Well, I told you it's one of the best I ever saw, right? It's solid. It's a very good one. And the next question is, okay, now what? So now we identified our image, we know what it is, and the next question would be, what can we do with that?
Yeah, so I mean at this point, we've really got to be able to figure out, if the latest tag didn't tell me something about where this image came from, all it says is that when I pulled it, it was the best known good image, hopefully that was the convention that somebody was using when they tagged it. It was the best known good image that somebody was supposed to pull. So, but now we actually have a problem. We need to actually know, where did that image come from? What is inside that image? And with this checksum, we should be able to start figuring that out. But you need to be able to do a search and see what other metadata is out there on this. We basically, usually, most things that are tagged latest, if people are following fairly standard naming conventions, most things that are tagged latest also exist under another tag.
Because latest will be a synonym, kind of symlink to another version which we want to find. So we can search by checksum and find this image in our Docker registry. And whoa. We just said that this is kind of a unique thing. How we ended it with 5 of them?
So this is a pretty clear answer here. So of course the latest tag was, unsurprisingly, in fact in this case it was still the latest tag.
That's the one that we looked at.
And then it looks like here you've got 2 different builds of the same Docker image. You built it twice, nothing actually changed. You did a no-op build. That happens sometimes. And it looks like we also have 2 repositories. So we promoted this image.
So those are different registries inside Artifactory, which we promoted between them with copy.
Yes.
So it started in dev, and then it went to prod. So that's why we have 2 copies. And when we actually were ready to put it in production, we also called it latest. So that actually makes sense.
Yeah.
Now, how do we figure out what went wrong with this image? We can navigate to one of them and take a look. And look, we have Docker info tab that actually, first of all, lays out all the Docker layers. And we can actually know what's going on. So let's take a look at this one. What did we do here?
We added a swamp-up war file. So, we did a fairly typical thing.
We didn't add a swamp-up war file. We added this wonderful file, 91D116F, and named it as a swamp-up war file. What is swamp-up, by the way?
Swamp-up is our user conference in Napa. So we had to plug it somewhere because marketing wouldn't pay for our airline otherwise. So
May 24th to 26th in Napa. Good wine, good weather, good talks. DevOps people, you should be there. Okay, so sorry, we got distracted. We took this file that we have no idea about and named it swampup.war and put it in our image, and that's our application actually.
Yes, and so far. I haven't shown you anything that several other Docker registries can't do, but this is about to change.
Oh yes. Now, what we know in our repository is how this image was built. We go to our build browser right here, and we can see that this is a Docker image that we built. First of all, we know that it was on Jenkins now. And we know it took 47 seconds, and we have a link to Jenkins. And that's pretty awesome, because in the Jenkins build results, we can see the commit that probably contains some code that broke our Docker image. didn't it?
That commit is probably pretty old. That's our Docker file commit.
And you think nothing actually changed there and there are no problems? You know what? It might be some environment variable. We can see them all right here. They were captured during the build. We might compare this build with the previous build and see maybe some dependencies changed. Or maybe we did something wrong and, you know, some kind of stuff around there.
So, yeah, a dependency changed, but only the war file.
And that's the war file that was changed. Oh, yes. And by the way, can we know what the war file was?
So this is really where it gets really cool. For those of you who are familiar with Artifactory, we've had a concept of build information for a long time. But we only recently added this concept of integrating build information with Docker using Jenkins pipelines. And one of the cool reasons to do this is to be able to track, hey, I downloaded a certain set of artifacts from Artifactory to set up my environment for my Docker build. And this will start allowing me to make a connection here of where did that war file come from.
So this is actually where universal artifact repository shines. You can use different tools as your Docker registry, and in our example as your Maven repository, and of course for whoever you put other stuff in their Docker images, you probably should use your NPM registry and your PyPy registry and your PHP Composer repository and etc. etc. And all of them are good by themselves, but the problem is, how do you correlate your Docker images with what went inside them? And everybody has to put something inside their Docker images. After all, the container idea is a very smart one, and no one in the world cares about empty containers.
I don't know. I like running BusyBox. It's fun. I log into BusyBox all the time and type ls just because.
Smart. All right. And none of you care about empty containers, and that's for a good reason. You put something inside. Now, it usually comes down to two different questions. What do I have inside a container? And that's the question that we are trying to answer now. Or the other way around. This application file, in which image it was contained. For answering both those questions, we need to correlate the application with the image itself. And if you run both of them on a single platform, like Universal Artifact Repository, like Artifactory, it's a very easy thing to do. I'm not claiming that it's impossible without, but it will be probably much harder without. But here, look at that. We have this war file listed as a dependency for our Docker build. By the way, it's not called SwampUp.
It is not.
But
we renamed it.
What we can do is take a look at it. And we will see here tons of information about it. And it has build of its own. This is actually our application build. It has its own Jenkins build results because it was a completely different build. It has its own commits, which are, of course, commits of our application code, right? And so here is the console output. You can take a look. And everything works. The build was successful, some tests passed, and we deployed our build info to Artifactory. And getting back to...
But we found a key information here, and we kind of just waved by it just for a moment, but it's a key point. We now have the git commit hash of the actual application that was probably causing the problem. Because when we diffed the two containers, we saw that basically the only difference was the application itself. So if I have a culprit in my mystery of the broken container, this git commit hash is probably will tell me what coder I need to call up and tell to fix this stuff.
You know what? This is Java. And Java might break for much more reasons than just an application commit. Any other ideas? Maybe the Java version was wrong in
True.
Jenkins when I compiled it.
That's also
true.
true.
How can I know it? Will my console output show me? Nah,
No.
It's not here. Where can I find it?
Back in Artifactory.
Back in Artifactory. You remember that we gathered all the environment information? we can go right here and ask for a Java version, right? And here it is. That's my Java version right there, right? So that might be a version. Or I want to compare with the previous build as we saw earlier. But you know what? Let's go back for our Docker image and take a look at something else. So I'll go here. That's my Docker image number 15. And I want to see this manifest file. What's this guy? I have some critical in red, and that makes me nervous.
So this is the other great product that goes with JFrog Artifactory, JFrog X-Ray. And so X-Ray meets a need common to Docker registries of a need to scan binaries. And we really thought when we built X-Ray that we're a company that has been studying the question of software binaries for a decade now, and that we really wanted to bring that expertise of we know about how binaries are put together, how they relate to each other, and bring it into the space of a simple question of how do I find a binary? If I have a problem with a binary, what is the impact on other things?
Interestingly enough, knowing the structure of binaries, all those and much more in the future, helps to analyze your software better. For example, what happens if you have a Docker image with a Debian package inside and a tar GZ archive inside and maybe an npm package inside? The traditional scanners that scan our Docker images will probably stop somewhere on the level of the system dependencies. They will see this Debian file and they will say, well, we don't know what it is, so screw you. We don't have any answers for you here. But knowing how to go deeper and deeper recursively can find hidden gems like we have in our build. So here we have this line of build 16 was scanned because we submitted it to Artifactory, and I find 10 issues. Ouch. Let's take a look.
Hidden gems, you said.
Yes, those are definitely hidden gems and not Ruby gems, others. Here is a huge list of our horrible vulnerabilities. And you know what? This one is interesting. This is Java. This is Commons file upload stuff. And it was found when we submitted the Docker image. And it was actually found on some levels deep. This is an Apache Tomcat dependency, which actually lives in the lib folder of Apache Tomcat system dependency that was installed inside this layer. We know that because we know how Apache Tomcat package looks like. We know that if we open the lib folder, we will find a bunch of jars there, and if we analyze those jars one by one, we might find a vulnerability. But you know what? Let's take a look at another one. This one, even more fun. It comes from our application archive. Now this guy is something that X-Ray never saw in its life. It doesn't know how to scan it. It doesn't know what it is. But the knowledge that this is a WAR file allows us to go deeper, because we know that it's an archive. Inside there is a lib folder. Inside there are a bunch of jars, and some of them might have those horrible vulnerabilities, right?
Yep.
And it works the same way for Bower, for NPM, for Ruby, for Python, not Ruby yet, Python, Debian, RPM, and what's not.
Yeah, and this can be inside or outside of containers, but we're at DockerCon, so we figured we probably wanted to do a container-based example. But you don't have to use containers to get this advantage.
And the other way around, we can go from bottom up. We can say, okay, now we know that this jar is a horrible thing to have. Let's ask which containers are impacted by it. In which containers we actually have this jar. And we can go and see the impact and say, okay, it is in a bunch of jar files, that makes perfect sense, and WAR files. And those WAR files are, where is it? Not this one? Yeah, those WAR files were built and deployed as a build by itself. And also they were contained inside a Docker layer. And this Docker layer is actually a part of some Docker image that was built and submitted to Artifactory as well.
Yeah.
And we are out of time, so we have a couple of, I did too much slides, right? Way too much. But we have that. That's an important slide because we want to point you to this page, jfrog.com/show notes, in which tonight you will be able to see the video of this talk, the useless slides, the link to all the links to the tools and the solutions that we talk about, right? And the feedback form and the raffle for thanking you to be here. And of course, the background here is just to remind you about how wonderful Napa is in the end of May. With that, thank you very much.